Imagine designing a building not by drawing fixed lines, but by setting up a series of rules. Think of it less like painting a picture and more like writing a recipe. This, in a nutshell, is the essence of parametric architecture. It's a design process where you define the parameters, the length, the angle, the curvature, the material, and a computer uses these rules to generate the form. Change one rule, say, the amount of sunlight you want in a room, and the entire structure fluidly adapts, recalculating and reshaping itself. It's a dynamic, living blueprint, one that responds to logic and data, rather than just a static sketch on a drawing board. This method is truly revolutionary. This approach is fundamentally different from traditional architectural methods, which have stayed much the same for centuries. Usually, an architect draws a plan, and that plan is final. If a major change is needed, it's back to square one, redrawing everything, which is a tedious and time-consuming affair. Parametric design, however, embraces change. It uses powerful software and algorithms to establish a relationship between different parts of a design. So, if you alter the height of a roof, the supporting columns and window placements might automatically adjust to maintain structural integrity and aesthetic balance. It's an intelligent and interconnected way of thinking about space. What makes this so special is its ability to create incredibly complex and organic shapes that would be nearly impossible to conceive, let alone draw by hand. Architects can now take inspiration directly from the intricate patterns found in nature, the veins of a leaf, the structure of a seashell, or the branching of a tree. The computer can translate these natural logics into buildable forms, resulting in structures that feel less like rigid boxes and more like living organisms. This isn't just about making things look curvy and cool. It's about using mathematical precision to create forms that are both beautiful and highly functional, a true marriage of art and science. This digital craftsmanship allows for a level of customization that was previously unthinkable. Every single element of a building's facade, for instance, can be unique, yet part of a cohesive whole. The computer handles the mind-boggling complexity of ensuring each of the thousands of individual components fits together perfectly. It's a move away from the mass-produced one-size-fits-all mentality of the industrial age towards a new era of bespoke, highly optimized, and deeply personal architectural expression. It is quite simply giving architects a whole new set of tools to dream with, turning abstract ideas into tangible, breathtaking reality. The magic of parametric design truly comes to life when you look at the iconic structures it has enabled. Take the Heydar Aliyev Center in Baku, designed by the legendary Zaha Hadid. Its form is pure poetry, a continuous fluid structure that seems to emerge from the surrounding plaza and flow upwards into the sky. There are hardly any straight lines to be found. This building would have been an absolute nightmare to design and construct using traditional methods. But with parametric modeling, the architects could define the rules for its swooping curves, ensuring every single panel and beam was precisely calculated and manufactured to fit into its unique place, like a giant, seamless puzzle. Another brilliant example is the Bird's Nest Stadium built for the Beijing Olympics. Its design appears to be a chaotic tangle of steel beams, but it is in fact a highly ordered and logical structure. The architects, Herzog and de Meuron, used parametric algorithms to create this seemingly random pattern, which cleverly conceals the supports for the retractable roof. The design process allowed them to test the strength and stability of this complex web of steel digitally, optimizing it for material use and structural performance long before a single piece was ever forged. It's a building that is as much a feat of engineering and computation as it is of architecture. These buildings are more than just eye-catching spectacles. Their parametric origins offer tangible benefits. The complex geometries often lead to incredibly strong and efficient structures. By simulating environmental factors like wind flow and sun exposure, architects can optimize a building's shape to reduce energy consumption. For example, a facade can be designed with thousands of unique panels that are angled differently to provide shade where it's needed most, thus cutting down on air conditioning costs. This makes parametric design a powerful tool for creating sustainable buildings that respond intelligently to their environment, proving that good looks and green credentials can go hand in hand. The process also revolutionizes construction. With a detailed digital model, components can be prefabricated off-site with incredible accuracy using computer-controlled machinery. This reduces waste, speeds up construction time, and ensures a higher quality of finish. It's a shift from building on-site to assembling on-site. Architects can even three-dimensional print-scale models or full-size prototypes to test connections and forms, spotting potential problems in the virtual world before they become expensive mistakes in the real one. It's a smarter, more efficient way to build, turning the construction site into a place of precision assembly rather than chaotic creation. One of the greatest advantages of this design philosophy is the sheer level of customization it offers. In a world moving away from mass production, parametric design allows for mass customization. Every client, every site, and every function can have a completely unique architectural solution tailored to its specific needs. An architect can design a concert hall where every single acoustic panel is uniquely shaped and positioned to create the perfect sound environment, a feat impossible to achieve with standard components. This ability to create bespoke solutions without an astronomical price tag is a game changer, allowing for unparalleled design freedom and innovation on a grand scale. Efficiency is another major selling point. While the initial design phase might be complex, the ability to automate repetitive tasks and instantly update an entire design based on a single parameter change saves an enormous amount of time and effort in the long run. This efficiency extends to material usage as well. Algorithms can calculate the most optimal way to cut materials, significantly reducing waste. For instance, a parametric script can figure out how to arrange all the unique facade panels on a sheet of metal to leave the least amount of scrap. This not only saves money, but also makes the construction process far more sustainable. However, this brave new world of design is not without its challenges. The most significant hurdle is the steep learning curve. Architects and designers need to become proficient in specialized software and develop a foundational understanding of scripting and algorithms. This is a far cry from the traditional skills of sketching and physical model making. It requires a different way of thinking, a blend of creative vision and computational logic. The high cost of the necessary software and powerful computer hardware can also be a barrier to entry for smaller firms, creating a digital divide within the profession itself. Furthermore, there's a risk that the focus can shift too much towards the technology and away from the human element. A building must, above all, be a good place for people to live, work, or visit. It's easy to get lost in creating fantastically complex shapes just because the software allows it, potentially forgetting about practicality, context, and the human experience. The challenge for the modern architect is to use these powerful parametric tools as a means to an end, to create better, more humane, and more beautiful spaces, rather than letting the algorithm become the sole author of the design. It's about mastering the tool, not being mastered by it. Looking ahead, the future of parametric architecture is incredibly exciting, and a big part of that is the integration of artificial intelligence. Imagine an AI that can learn from thousands of existing building plans, structural engineering principles, and environmental data. An architect could simply input a set of goals, a 200-person office building on a specific site, with a target for maximum natural light and minimal energy use. The AI could then generate not just one, but hundreds of viable design options, each optimized for those criteria, giving the architect a fantastic starting point for refinement. This would massively accelerate the creative process. This partnership between human creativity and machine intelligence could solve some of parametric design's current challenges. AI could make the sophisticated software tools much more intuitive and user-friendly. Instead of writing complex code, an architect might be able to describe their design intent in natural language or through simple sketches, and the AI would translate that into a detailed parametric model. This would lower the barrier to entry, allowing more designers to harness the power of parametricism without needing to become expert programmers. It promises to democratize this advanced design methodology for everyone. Moreover, AI can push the boundaries of optimization and sustainability even further. An AI-powered parametric model could run real-time simulations throughout the design process, constantly adjusting the building's form to respond to changing weather patterns, energy prices, or even the predicted movement of people within the space. It could suggest novel materials or construction techniques that the human designer might not have considered. This could lead to buildings that are not just static objects, but are truly responsive and adaptive systems, learning and evolving over their lifespan to be as efficient as possible. Ultimately, the goal is not for AI to replace the architect, but to augment their abilities, creating a powerful synergy. The architect's vision, empathy, and understanding of human culture will remain essential. The AI will serve as an incredibly powerful assistant, handling the complex calculations, generating possibilities, and freeing up the architect to focus on the bigger picture, creating spaces that are not only structurally sound and environmentally responsible, but also inspiring, meaningful, and beautiful. the future of architecture isn't about choosing between the human hand and the algorithm. It's about bringing them together to design a better world, one parameter at a time.